Hi, everyone in room. Welcome. So I am Dr. Bridie Schultz. I'm one of the people working for the Australian Citizen Science Association to build the Citizen Science Corners across public libraries in Australia, of which you are currently sitting in, which is fantastic. I have the great privilege today of welcoming Marilé from NASA, like the actual NASA. You can see it in her jacket, which I've forgot to say before is literally the best jacket I think I've ever seen. And Rosalba from NASA as well. So these amazing women work for the NASA Global Learning and Observations to Benefit the Environment, otherwise known as GLOBE program. Marilé was the recipient of the 2017 Women of Color STEM Award for Educational Leadership. And I just think that that's one of the coolest things ever, not to mention that she's one of the nicest scientists I think I've ever met. But I will leave it in your capable hands, ladies, to tell us about all things clouds. And as someone who's never been to Western Australia, I know I'm certainly going to learn a lot. But I will pass it over to you, Marilé.
Awesome. Well, hello, everybody. I'm so excited that we're connecting. Thank goodness for technology, right? We are together just breathing different air, right? My air has a lot of cat hair right now because my kitty cat is here. Your air has some ice cream, and hopefully it smells really, really good. Um, and so let me do a quick introduction. So I'm going to let Rosalba is going to help me with questions, and she might put some resources in the chat if anybody has any questions. But Rosalba, go ahead.
Yes, hi, my name is Rosalba Giarratano. Like Marilé said, I'm going to be helping in the chat. But yes, a very quick introduction. I'm originally from Mexico City, but I live now in New York City, specifically in Queens. I'm a science outreach coordinator with NASA Langley. And some of the things that I love doing, in addition to science, is playing board games with my son, with my mom, watching TV whenever I have time, not a lot. And I am also trying to learn Japanese. That's it. And I will pass it again to Marilé.
Yes, thank you, Rosalba. Thank you for being with me here. So my name is Marilé Colón Robles. It is in Spanish, just like Rosalba's name, because I am from San Juan, Puerto Rico. That is a tiny island in the Caribbean. That's where I was born and raised, but I am right now in Yorktown, Virginia, USA, and we both work at NASA Langley Research Center, which is the very first of all the NASA centers, which is very exciting that we have so much history. And so NASA Langley started in 1917 when the Wright brothers took flight not too far from here in North Carolina. I am the project scientist for Globe Clouds. That just means that I get to come up with really cool research questions, work with scientists, and work with people like Rosalba on doing activities, coming up with activities to help you learn about clouds. I love hiking, puzzles, playing volleyball, music, and traveling. And so you might not have heard of Puerto Rico, but it's in the Caribbean. It's the smallest of the Great Antilles, or the largest of the smaller Antilles. It's in the Atlantic Ocean and in the Caribbean Sea to the south. So all my life, I lived through hurricanes, which is another word for typhoons. Those were the big storms. But when I was little, so here's a picture of me when I was 6 years old, I loved animals. So here are the two of my favorite animals. Does anybody know the names of those animals? How about the name of that lizard? That's my favorite type of lizard.
We got one goanna.
Almost, yeah.
Is it a Komodo?
Yes, it is. It's a Komodo dragon. And so I grew up with lizards, not this big. They were teeny tiny. My aunt actually would grab them, and if you tap them, the small ones, in the mouth, they open, and then you can put them as earrings. So that's how we have fun with lizards. I don't know what. That was my aunt. I know. I'm so sorry. But I grew up around lizards, so this is my favorite type of lizard. So whenever I know that there's a zoo nearby or something, I look for monitor lizards. Now, I also love sharks. I grew up in the coast, so I knew where to go to look for baby sharks, and not this type of baby shark, but actual baby sharks. And depending on the type of shark, where they would lay the eggs and the baby sharks would grow. Now, this is my favorite type of shark, and I still want to swim with this type of shark. Can anybody tell me the name of this type of shark? Any guesses? Yes, it is a whale shark. That's right. Good job. So those are my favorite animals. I also played music. You can raise your hand. Does anybody play music or an instrument or was in a band or anything like that? I see people pointing but say no. And so I did flute. And the reason why I bring this up, because I feel it helped me become a scientist like I am now, because there's a lot of math in music when you're reading different music. You're also learning kind of like a different language when you learn how to read music sheet. And to become a scientist, I had to learn how to do computer programming and coding to look through all the data. But I also, you notice I'm having the flute. So in this picture, I was practicing to do a solo with the pianist. So I also learned to be able to walk on stage by myself and present, which I have to do. In this case, I was playing the flute. But as a scientist, I have to go to conferences and present results. And so music helped me. Now I don't have a picture here, but I also play volleyball. Does anybody play a sport? You can just raise your hand. Oh, okay. Awesome. Yeah. So I feel that sports help me a lot to learn how to work in a team, how to communicate. Volleyball is a really high speed sport. I was the setter, so I got to play really high level. So I had to decide, but also communicate to all the three hitters that were in the front, which one was I picking to hit, but I also had to hear which one was ready to actually hit the ball, these surprise attacks that we would do. And that's really important because Rosalba and I work in a very diverse team at different NASA centers. So communication and working in collaboration with other teams is very important. And so we get to work with the GLOBE program. So GLOBE is NASA's largest and longest lasting citizen science program about the Earth. It started 30 years ago when students, teachers, and scientists all came together and came up with the steps, which we call protocols, but the steps on how to make observations by students or by parents or anything like that in a way that then can be used in research. But it's also all around the world. There's 127 different countries in GLOBE. Australia, I get to see a lot of observations from GLOBE from Australia. And so these steps help us make sure that we're all talking that same language and be able to compare them from continent to continent. And the picture that I have here above is from one of the meetings that we had, and it's all the students that are part of it. This is the night where everybody wears their dress outfits from their culture, so you can see all the different countries that get to come together. Now, the team here, Rosalba and I, we're at NASA Langley, where we compare your observations to satellite data. So the GLOBE program has an app called the Globe Observer app. You can download it. It is free to use. It'll ask you for an email, and it'll create an account to keep your privacy, but be able to record your observations of clouds, land cover, trees, mosquito habitats. And then whenever you make a cloud observation, we'll look at it, we'll pull it down the next day, and then send you within 24 hours a NASA personalized email with your observations compared to multiple satellites. This is super cool. Now I got the question about talking about clouds and why do they change and why certain areas you get a lot of clouds and sometimes in some you don't get a lot of clouds. And so clouds are really unique. And so you have water vapor, or right, all this moisture rising, and it rises, and as it rises, it cools and it gets bigger. So when you study meteorology, which is what I studied, atmospheric sciences, you study how air moves up into the atmosphere and down. It's the physics applied to the atmosphere. So as it rises, it expands, it cools, and it could condense. So from gas, it can change into liquid. And I actually got to fly inside and outside of clouds, inside of airplanes. That's what I got to do as a student, a graduate student. And so these little droplets are inside of the cloud. Now, they're not very big, and that's why they don't fall. When those droplets get really big, that's when you get precipitation as rain or snow, and that's when it falls. All these water droplets inside are kind of floating in the air, but they reflect the light of the sun, make it look white, and that's why clouds are white. Unless they're ready to rain, and then they start looking darker, and that means that the light from the sun is reflecting away from you, which makes it look dark. Now, this cycle happens a lot and a lot and a lot. And then when we look at data throughout many times throughout a year, multiple years, we get the patterns. And the patterns is what we call climate. And so in Australia, there's a lot of patterns. You guys live in a really cool place. I totally want to go there and study more the meteorology, because you're surrounded by water. So a lot like where I grew up in Puerto Rico, surrounded by water. But all that water, you have different temperatures of water now. They interact with the air or the land around it and create different things. And so you have the monsoon happening, and it happens in this area, and then you get those cloud bands across the continent. The Indian Ocean will warm up at a different rate. Remember, warm air causes that air to rise, and you have the clouds, and then that moves over, and that can create some clouds. You also really close to Antarctica, which is on my bucket list to go. Has anybody gone to Antarctica in this group yet? Super cool. I have people that travel to Antarctica and make cloud observations for me. It's really cool. And these ships, and there's some ships that live from Australia. All that moisture, again, that cold air moves over the ocean, it's warmer, and it causes all these storms. And then you have the El Nino, which is happening right now. I think we're going to move into La Nina here soon, so you might see even more rain in your area. But all these things are different patterns based on when we looking at multiple times at the clouds. Now, you might have had this question of what is this difference between weather and climate? Oh, and I didn't mention, if anybody has a question, you can raise your hand and ask me immediately. It's not a problem. I learned about the difference between weather and climate really quick when I went from the tropics to and moved to the United States. I moved to Illinois, which is very cold. It snows. I never seen snow. So the options in my closet, if you think about it, did not have caps, did not have coats, did not have boots, because I lived in a very different climate. So when I moved to a different climate, I had to add options to my wardrobe. Weather is what you pick for that day to wear. So it could be sunny, it could be rainy, it could be cold. It's actually pretty cold for us, Rosalba and I, right now. I heard that it's pretty hot for you all. That's why you're eating ice cream. But all the options to choose will depend on your climate. So I have, every time I've moved from place to place, my closet, the clothes that are hanging up in my closet have changed because of the climate. So the weather, when you look at it over and over again throughout many years, you get the patterns, and that would be climate. Does that make sense? Okay, I got a head nod. Now I got this photo about an hour ago. This is how it's looking an hour ago from the satellite. So this is looking from space, looking down. Everything that's white in this picture is a cloud. Isn't that cool? And so there's clouds. These look like teeny tiny, puffy, I would call them puffy clouds. Here are bigger puffy clouds. But these are not puffy over here. Do you see my, I made sure to have a pink, big pink, what do you call it, a pointer. These don't look puffy. How would you describe these?
Wispy.
Yeah, wispy, like stretchy, maybe, right? Even if you stretch out cotton balls. Just by looking, oh, and this one, this is total thunderstorm. I can tell that's a thunderstorm because it kind of looks like it's going splat, right? Like somebody just spilled a bunch of ice cream somewhere. But what that means is that it's growing upwards and it's going splat into the top of the troposphere. So this is total thunderstorm right here. Based on when we call clouds, the names are based on how they look. And just from satellites, also I can tell kind of what types of clouds these are. These are cirrocumulus clouds. These are stratus clouds. This is total thunderstorm. Now let's practice those names. Let me show you an animation of how it's looked all this past year. And so NASA has, can you see that now, the world view? NASA has a free software called Worldview. It'll let you pull in any type of data for any dates. And I was able to do an animation. So this is starting from February. And again, everything that's white is cloud, except for these things. These are sun glints. So just like the sun shines in our eyes sometimes, that's just sunshine reflecting, bouncing back to the satellite. Look at all those storms. We are in April right now. They're coming from Antarctica, but I also see these. So anything that's twirling is definitely a thunderstorm. You can see these small ones popping up around Indonesia. Let's move into December. So you see a lot of the storms coming from Antarctica. But now all these storms, these are typhoons over here. Let me see if I can stop it. There were a few typhoons happening here. And then you can see how from the Indian Ocean it starts activating and moving. So it's a really cool place. Oh, did you see those bands? And so as the heat from the earth starts heating up the oceans and different parts of the oceans, you'll see the different types of storms forming. So either from Antarctica moving up, and then you get those long clouds. You see that? You can get these typhoons up here from the easterly waves. And look at how India and Indonesia are blowing up right now with clouds because of the start of the monsoon season. But now it's dry right here. You see that? But everywhere around there's clouds. So it depends on all those cycles and all those patterns. Right now we're in September, so you see it's pretty clear here, but very stormy down here. The polar regions are the stormiest parts of the world. You see those clouds starting to pop up here. Oh, you see the typhoons. Yeah, that was a big typhoon right there. How tight the eye was.
We call the typhoons cyclones here.
Cyclones, yes.
Yeah.
We call them hurricanes in the Atlantic, typhoons and cyclones, yes. Isn't that neat how you can look at all that data? Just look at the images, look at the storms. Big clouds, small clouds. And then you have winds coming from the east to the west, but you also have lower west to the east. So that's why Australia is just incredible with the climate. You do have some mountains, so the mountains will affect some of that too. And the island that I grew up is teeny tiny. It's 100 miles by 30 miles, but it has mountains right in the middle. So everything is green in the north and then very dry and desert in the south. So even in such tiny areas, the topography plays a huge role. Now, this is the airplane that I get to fly in. So when we study clouds, we study them from satellites. We study them from citizen scientists just like you. We also fly airplanes. And so this is a cargo airplane or C-130. And what happens is all these areas, they put all the instruments, and then when you fly inside and outside of clouds, you can measure things. Now, are all clouds the same? So 2 basic questions. Do all clouds cast shadows? What do you think? Do all clouds cast shadows? I got a yes. I see some yeses. So the clouds that cast shadows are very thick, like thunderstorms. And so a lot of the droplets are really big. But high clouds, so clouds that are up where the airplanes fly, are actually ice crystals because it's so cold. If you've flown in an airplane, you know that it gets cold. And so the higher you go up in the atmosphere on our Earth, the colder it gets. So all these clouds up here are ice crystals. So they don't really create shadows. So no, not all clouds cast shadows. Isn't that incredible? It's one of the things that I learned. And do all clouds produce rain? Next question. I see a lot of heads. Perfect. Not all clouds produce rain. But how many do? Do you want to guess?
A lot.
I hear a lot. How about the adults?
Yeah.
What if I tell you that there's only 2 cloud types that produce rain? 2. There's only 2. You just see them a lot. So one of them is my favorite cloud type. I didn't tell you, but my favorite cloud type are thunderstorms. And when I moved from Puerto Rico, which was hurricanes, and I moved to the Midwest where we get tornadoes. This is a picture of a supercell thunderstorm. In the US, you can see about 200 tornadoes per year. It's really unique because of the water and the mountains and how it's cold, mountains, and water. That's why they get so many thunderstorms. And you can see the green. Do you see a bit of green there? That means that there's hail inside of that storm. We really don't know why, but when you see some green in a storm like this, it means that there's hail inside. And then the other type is this one, which is a nimbostratus cloud. These are ones that are really flat and they cover the entire sky, and it kind of rains for long periods of time. Usually more in the winter time, you'll see this cloud type. But those are the only two cloud types that produce rain. There's three main types of clouds. Can you do this? Three main types of clouds. There are many, many cloud types, but three main categories. Okay, the first one is cumulus. Stratus, that's right, stratus. And then what's the last one? It's a weird word.
Nimbus.
Nimbus is a prefix or like a descriptor. It means precipitating. The third one is cirrus. So cumulus, these are puffy low clouds. Stratus are flat clouds, and they cover the entire sky. You can't even tell where the sun is. And then cirrus clouds, which are nice and fluffy. So there is a cloud dance. And yes, I am on YouTube, so you can watch me dance with my girls. These are my two girls doing the cloud dance. But I'm going to invite you to do the cloud dance. So first we're going to practice. So I'm going to stop sharing. We're going to practice. So you can put your arms up if you want to participate with me. We're going to do the cloud dance right now based on those three category types. Okay, so the first type is cumulus clouds. So cumulus clouds are these puffy ones. The air moves up in it very rapidly. So let's move some air up. Move it, move it. Very good. Okay, cumulus. Now let's do the second type. The second type was stratus. Remember, flatten in every direction. Now this is like a really beautiful stretch. It's in every direction. Enjoy it because it feels so good. It feels so good. That's right. Stratus. Now, do you remember cumulus? Show me cumulus. Yep, cumulus. Stratus. And then the third one was cirrus. Now, cirrus, they're really high clouds, so put your hands as high as you can. And then they're wispy or stretchy, so let's stretch that air. There you go. Stretch, stretch. There you go. Now, we did this dance with astronauts at NASA, and then they went outside and they were going, oh, that looks like a cumulus, and they went like this. You will remember your types of clouds. Now, if I show you a picture, will you know to do the right motion? Yes? This is cumulus, stratus, cirrus, right? Let's see how good do you do and how fast can you get it right. Okay, first cloud, cumulus. Show me cumulus, 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 cumulus. Very good. Cirrus. You remember cirrus? Yes, very good stretch. Cumulus again, cumulus, cumulus. Stratus. Excellent jobs. Enjoy that stretch. Cirrus. One more time, cirrus. Nice. I love those hands. Stratus. Cumulus. Now, if you continue to do this cumulus, you'll get a cumulonimbus cloud, and then you'll get lightning and rain. Awesome job. Awesome job. Now, like I said, these are the 3 basic categories. If you combine them with other things, you'll get all the other cloud types. There's about 10 basic cloud types. Basic cloud types. You have the cumulus, all the puffy ones. Nimbus, I heard nimbus, that means precipitation. So you add it to the word cumulus, and now you're saying thunderstorm. You have alto. Now this threw me off because for Rosalba and I, alto means high, really high, or tall, right, in Spanish. But remember, I'm a musician, so if I think music and I think like choir, you have the sopranos, the altos, and the basses. Soprano, alto, bass. Alto means mid-level. So these are cumulus clouds at the mid-level, alto cumulus. And then cirrus, we have it here, but we use also the word cirrus to mean high. So now a cirrocumulus cloud is a really, really high cloud where the airplanes fly. So the best way to tell is you can stretch your hand, make a fist with your hand. If the cloud that you're looking at outside is as bigger or as big as the fist, is a cumulus cloud, is a low cloud. If it's smaller, then try the nail of your thumb. If it's about the size of your thumb, then it's an alto cumulus cloud. And if it's even smaller, but about the size of your pinky, the nail in your pinky, it's a cirrocumulus cloud. Because these puffs are really far away, so they look teeny tiny from our perspective. And then you have something similar with the stratus type clouds. And then once you learn all of these, you can learn all the different cloud types. Now, Rosalba, here who is connected, designed the idea for the Nube card game. And I hope you all get a chance to play it. It is available right there next to you. But there's ways where you can play it. I know, isn't that amazing? So you can learn and become an expert in the cloud games. Now I'm going to play this video. It's going to just walk you through how to make observations if you were to download the app. It's pretty simple. It works in any type of phone, which is incredible. And anywhere you are, if you see some cool clouds, or if you don't, a lot of the observations I've gotten from Australia are from smoke or even haboobs as well, which are incredibly difficult to see from satellites. But the app will read where you're at, and then it'll be 3 basic questions. Are there clouds, no clouds, or if there's something blocking the view of your clouds? Then I'll show you pictures to tell how much of the sky is covered by clouds, no matter the type of cloud. And it's in ranges. You don't have to come up with a very specific number, and you pick the one that you think is the best. Depending on how much clouds there are, it'll ask you for the deepest blue that you see in the sky. This tells us how much aerosols or things are in the air. Then you look across the way and you look for your visibility. Again, it tells us information about how clean your air is. And then if you want, it'll ask you for very specific questions about the types of clouds. We just went through cirrus, cumulus, stratus. Satellites, they tell us if there's clouds or not, the temperature of the clouds, but they don't tell us the type of cloud. You do that, and that's why we need your observations. Then the opacity or the color of the cloud, and then what's in the surface. When we were looking at that image, everything that was white was a cloud in Australia. But where Rosalba and I are at right now, there might be something else that's white on the ground that is also white. Can you guess what could it be?
No.
Snow, that's right. So you need to help us distinguish between snow and clouds. Then the coolest thing is you put the letter for the direction you're looking at, like north, south, east, west, into a circle, and that picture is taken automatically. Then you can save it or send it when you're back at home, and then it gets to me, and then we look at satellites, which satellites were right above, and send you that personalized email. So we compare to what we call low orbiting satellites. These are satellites that go around the Earth, and every few days it goes over the same part. If you download the app, you can actually tell it to let you know when the satellite's right above you. And then we also look at geostationary satellites. These satellites are really far away and they look at the same spot. So even as the Earth rotates, it's always looking at that same spot. So that's how we were able to see all the storms in Australia. Now you'll get an email from NASA saying, hey, thanks for making an observation, and it'll send you a link. And maybe in 2 days, it'll send you another link because it takes us some time to get all the satellites. But when you click on the link, you'll see a table, and in the table, you'll see your pictures and what you said that you saw, and then all the satellites that were at about the same time at about the same location. And then you can compare to see, because not all the satellites agree or see the same things. So that's why your observations and the different satellites are so important, because it gives us a more complete view or story of what's happening in the atmosphere. Now, one of the hardest things to do is total cloud cover. It's estimating cloud cover. How hard is it, Ms. Rosalba, out of all the things that we have to do?
It is very, very tricky. Yes.
It is very, very tricky. So we're going to teach you an activity that you're going to do there once we say goodbye. And you're going to try and stump each other. You're going to try and have people guess what you did. So for this activity, you're going to need blue paper. You're going to need white paper. And you're going to need glue. It may be scissors. Scissors would be great, but not necessary. And not a cat. You don't need a cat. You can leave the cat out. But the blue paper will be your sky. The white paper will be your clouds. If I divide this paper in half, so when it was complete, it would be 100%. If I divide it in half, what percentage do I have of the paper now that you're seeing? What is half of 100%? 50%. So if I were to use all this paper and put it on this blue sky, then I would have a 50% cloud cover. Now, if I were to split it in half again, and I open it up, but I only use one rectangle out of these. Now I have 1, 2, 3, 4. What would be the percentage if I only use this one rectangle? What is 50 divided by 2 now?
25.
25%. That would be 25%. Now, let me stop sharing so you can see me better. You could even go a step further and estimate how much you would need of paper to have 10 rectangles. So I have 5 rectangles on this side, 5 rectangles on this side. So 5 rectangles would be 50%, it would be the same as half. But if I only use one rectangle, what would be the percentage? 10%. 1 out of 10, 10%. So you can cut however many rectangles you want, cut them into pieces to make your clouds, and then try and have people guess the percentage, the cloud cover. We as humans tend to overestimate. So this is where this activity comes really, really important. So for this one that I'm holding up, what do you think is the total cloud cover in this cloud scene? I'm going to put some options up in the screen. And some options: A, 10%, B, 20%, or C, 30%. I hear A. Any other guesses? Let's
I
see.
got B at first, but then I'm not sure.
I know. You're like, oh my gosh, this is so stressful. Yes, it is 10%. And remember, when you do the cloud cover, we have ranges, so you don't have to be very specific. So after you do this activity, you'll be even more prepared because it'll be easier once you do the ranges. Now let's look at this example, which a student at a library made. So you have it here. Now this definitely is more than 10%. What do you think it is? Is it 50%? 70%? 90%? How many rectangles did they use? Just I was looking like, I don't even know. What did you guess?
B.
A,
I'm
50?
with B. We've got two Bs.
You got 2 B and 1 A?
One
Rosalba, what do
C.
you think?
I think B. I think
You
B.
think B? Okay, okay. Yes, good job. You got B. Now, what happens if you put them all in one corner, my friends? That becomes harder. These look like stratus clouds, right? Stratus clouds. Okay, what is the percentage of this one now? A, 10%, B, 20%, or C, 40%? I hear B. B, 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 B. Are you right? Yes, you got it. Very good. So, as you prepare to do this activity, make sure that you use all the paper that you cut out. So let's say that you divide it into 4 parts. Make sure that you use all that rectangle, right? So you cut that rectangle. See, this is why scissors are optional. And then I start breaking them into clouds. Make sure you use every single piece. Sometimes I've seen that somebody does that and then doesn't include that. You have to include it in order to make the correct percentage, right? I've also seen people that then divide this into half and then tell me that it's 13.5% or 12.5%. You can be fancy like that as well. I've also seen people where they leave them curl like that and then they call them cirrus clouds. That is really creative, okay? But make sure that you use all the pieces that you cut. I don't know if you noticed, but you cannot put one piece on top of the other. So when you're putting it on your white paper to make it the correct percentage, you can put them really close, but not on top of each other, okay? And so you don't forget, because sometimes we forget, make sure to write the percentage in the back. Now, are there any questions? Because now you're going to do this activity. So before Rosalba and I probably go to bed or maybe watch some little bit TV before we go to bed. Are there any questions for us?
There's one that's a big one on the Broome Weather Group usually, which is about the Broome Dome. So we have our radar here. And why do the clouds never reach within our little circle? They just always go around us.
Like, why
The
do
very-
clouds always form around and not on top? Is that the question?
Yeah.
Or why do you
We might
see
have-
it?
I'm a storm chaser here.
Yeah.
I'm familiar with the weather now.
Yeah,
Do with sea breeze, boundary lines. Warm, it's
Yes.
cooler water over the ocean as opposed to the land. So hot air rises inland, doesn't rise over the ocean.
right.
They get cut off
So-
from the ocean. So they
Yes.
don't make it over the bay.
Yes. So those little intricacies are very important. And this is why local meteorologists or people that grew up in that area are the best meteorologists. So where between Rosalba and I is Pennsylvania. In Pennsylvania, the state of Pennsylvania, and it has a mountain range. It's part of a mountain range that's sideways. And it's on the water. The eastern part is on the water, but something that happens is as storms move up, that cold air gets trapped inward, and it's only unique to that little portion. My brother lives in Oklahoma, in the middle of the country in the US, and there's a little butte. There's a butte in this near where he lives, and all the thunderstorms happen east of that butte. So again, those little portions that happen are super important. Now, other things that happen, which is I think where I thought you were asking, is that for some reason where there's a lot of meteorologists, the clouds break apart, the really good thunderstorms don't happen, and they go around the city and happen in the next city. So when I would go storm chasing and stuff, it would be east or west of our university. You would see the storm, we would get excited, and then I would stop, go around the university or around the radar, and then start up again after our university, like westward from the university. Why does that happen? We don't know. But where there's a lot of meteorologists, really good storms do not happen. I don't know why, but that's something funny that a lot of us have noticed. Any other questions?
I had a question, but I think you might have answered it with your
That's fine.
explanations of Philadelphia and that before, because my question was, are there weather events that happen in Australia that don't happen anywhere else? But then you gave that example of those really place-specific occurrences. So I guess now
There
my
are.
question.
There is. So I remember when I was in grad school, learning about, I'm not exactly sure what they're being called right now. I may look young, but it was a long time when I was in grad school. So science always changes. So the names might have changed, but it's kind of like a dry, what we would call a dry hurricane or a dry cyclone that you get in the northern part of Australia. And I think it relates to the heat that you were talking about, the heat and the difference between the water and the land. They have this shape of hurricanes or cyclones, but instead of being fed by the water, they're being fed by the heat of the land. And they're really unique, and they only occur in Australia and only occur in that northern portion of Australia. Something similar happens near Alaska. It looks like a hurricane or a cyclone, but technically we cannot call it a cyclone because it's so cold up there, right? Cyclones are warm centers. storms, but it has that structure. It has that eye that you see in cyclones. So it's really, there's still really unique occurrences of storms and clouds that we still need new scientists to study them.
I like that. I know I want to be a new scientist. I always change what type of science I want to do. Were there any other questions from Broome?
I thought I heard something a while back where cyclones and hurricanes spin in opposite directions because they're north and south of the equator. Is that true?
It could be. I always think of it as more of the name that people give it. So to me, cyclones are India, in the Indian Ocean, Australia. Then typhoons are in the Pacific, in the Western Pacific, hurricanes in the Eastern Pacific and Atlantic. But they do spin differently, right? And that's the Coriolis force. But I've always thought that it's, and maybe it is true, but I've always thought that it's depending on the culture of the people and the name that they want to use.
That makes sense. That makes a lot of sense. So I guess what you're saying is they'll always spin in sort of different directions, but one spinning clockwise in one country and spinning clockwise in another country will be called different things just because of the people who live there and what they're used to calling them. Because the event that you described that happens in Australia that you call dry hurricanes, I wrote that down because we always, where I grew up, we call them willy willies. But now I'm going to call them. Now I'm going to call them dry hurricanes and sound a lot more.
I don't think you should change it just because you talk to me. I like willy willies.
I think dry hurricane sounds a lot cooler.
Now, the name hurricane, and the reason why I say this is I'm from Puerto Rico, so the natives of the Caribbean islands were the Taino, or one of the groups were Taino people, and they called the wind god Huracan, which is where we get our word hurricane. And the symbol for that god is the symbol we use now for those types of storms, hurricanes, cyclones, and stuff. So it comes back to the culture.
That's so cool.
But you're probably right. Anything north of the equator is either a typhoon or a hurricane, and anything south is a cyclone.
I love that. Were there any other questions from Broome? I think that I know I've certainly learned a lot today. I thought I knew about clouds. Turns out I didn't, but I do now. So thank you so much, Marilé and Rosalba, for giving us your time today. I do respect that it's 9 o'clock at night where you are, but we thank you very much. And I think they very much deserve a big round of applause, especially from the room in Broome. But thank you very much for coming, and I hope Paula from the library there in Broome will take photos of the cloud cover game that you guys play now, because then we could potentially show them to our NASA friends and see if Rosalba and Marilé get it right as well.
Oh gosh.
So we might be able to stump the NASA scientists.
That's right. That's right. No, I loved every second. Thank you for letting us connect with you in your morning. I appreciate that.
Thank you very much, everyone.